All right, good morning, everyone. I hope you guys are doing well. I think you probably found these problems a little bit more challenging than the previous problems in this section. Obviously, they're the open-ended or word problems, so that typically makes them more challenging. So let's get started. So we needed to complete 67 through 72 on pages 381 and 382. So 67 through 72, that is actually just on page 381, now that I realize it. So 67, uh, first one says find the domain, the x-intercept, and vertical asymptote of the logarithmic function and sketch its graph. So as I told you whenever we learned how to graph natural log functions, I'm perfectly fine with you just using your graphing calculator to do this. However, I am going to go over this for these two and kind of explain what this would be and the way we would do this if we were just trying to do a rough sketch. So what we would have, and I'm just going to do this on the right-hand side so we can still look at the actual problem while I'm doing this. But if we had a coordinate plane that looks like this, a generic log graph, if you remember, an exponential looks like this. So a log graph looks like this. And that's basically a generic logarithmic function. Just looks like that. So that's a good starting point for a parent function to now look at 67. And if you look at that one that I just underlined, you can see that there's a negative x in there. And that negative x is on the inside. Therefore, it is going to reflect about the y-axis. So it's going to take the graph that you can see that I just drew, and it's just going to flip it around, and it's going to look something like that. Now, as previously stated, there is an asymptote right where I'm drawing it right now. You can see that red dashed line. So the asymptote is the y-axis. When you reflect that black graph into the red graph, the asymptote does not change. So it says find the domain, the x-intercept, and vertical asymptote of each logarithmic function. I'm going to start with the vertical asymptote. The vertical asymptote for the red function as well as the black function is x equals 0. The domain for the black function, let's talk about the black function for a second. This function would be 0 to infinity, both with parentheses because it doesn't actually touch the y-axis. Now, when you flip it over and turn it into the red function, the domain reverses and it becomes negative infinity up to 0. And you can see the red function never hits the y-axis. So that's why it's at 0. The last part of this question is they asked you to find the x-intercept. Now, when we looked at exponentials, I'm going to draw a little exponential down here. An exponential goes up like this. This point where it crosses the y-axis right there, that is 0, 1. And we know that exponential and logarithmic functions are inverses of one another, and inverses ordered pairs flip. So this ordered pair in this exponential graph, which was 0, 1, up here on the large one, on this one, becomes 1, 0. Now, when we flip-flop that graph and we do the transformation, which is reflect about the y-axis, that point ends up being right there, which is negative 1, 0. Okay. Now let's look at number 68, because there's a lot more going on. Not a lot, but there's one more transformation going on in this graph compared to the other one. So again, I'm going to start out with drawing my coordinate plane, and then I'm going to draw a basic logarithmic function, which looks like this. That's our parent function of a log function, and this point right here. And you can see number 68, there's a couple things going on. Now, I don't like how they have that written, and I would prefer to write it like this. F of x equals natural log of negative x plus 3. I think that's an easier way to do it because there's two things happening to that. The first thing to realize is right here, the x, there is a reflection about the y-axis. So the first one is reflect. Sorry for the writing. It's messy. It's tough to write on these iPads what I'm doing. The second one would be a shift, and normally +3 on the inside would mean shift to the left. However, because of this negative right there, that reverses that +3, and this is actually a shift right 3. All right, so let's see what that makes our parent function turn into. So the first thing we would do would be to reflect about the y-axis. I'm going to draw it. I'm actually going to do a series of drawings here. So the first one would look like this. And then we would need to take that graph, and you can see there's this dot right here at -1, 0. And that's going to go to the right 3. So the new graph, the translated one, is going to go to the right 3. This dot is going to go to the right 3, and you're going to end up having a graph that looks like this. Now, one thing to keep in mind, there's an asymptote right there at the next one. This would keep going over here like that. Okay, so to answer the question, 1, there's the graph. 2, it asks you for the x-intercept. You can see our x-intercept in this graph that I'm going to circle, this one right there. The x-intercept in that one is at 2, 0. So the x-intercept is 2, 0. It asks you for the vertical asymptote, and the asymptote is one spot to the right of where the x-intercept is. It's this pretty terrible semi-dashed line. I'm going to put a purple down through there so it's a little easier to see. You can see that goes through x equals 3. So therefore our x-intercept, I'm sorry, our asymptote is x equals 3. And the last thing that it did is it asks us for the domain of that function. And you can see that function exists everywhere to the left of 3. And so we would say that by saying -infinity to 3 with a parenthesis. All right, that one was a lot tougher than the last one because there was more than one transformation. Okay, looking forward, that was 67 and 68. And then we needed to do up to 72. So then the next 4. It says use a graphing utility to graph the function and then be sure to use an appropriate viewing window. So the first one is natural log of x minus 1. So if we go into here, hit y equals, hit natural log, x minus 1, close your parentheses. Make sure you hit zoom 6, which gives us a standard window to look at, and you can see there's the graph, natural log of x minus 1. The next problem they wanted us to take a look at was natural log of x plus 2. And as a side note, before we do this, that plus 2 on the inside, x plus 2, would actually shift this graph to the left too. And so if you remember what the base parent function looks like, it starts here and goes up. This graph is shifted to the left too. The next one is natural log of x plus 8. As you can see, the plus 8 is on the outside. Therefore, if you remember from your transformations, plus 8 on the outside is going to shift that graph up by 8. So we're going to have natural log of x plus 8. You can see, shifted the graph up by 8. And the last one from this set is 72. And we have 3 times natural log of x minus 1. Now the 3 is multiplying, so that is a vertical stretch by 3. And then we have this minus 1, which is also on the outside, so that is a shift down 1. So we have a stretch vertically by 3 and a shift down 1. And so that one is going to be 3 times natural log of x down 1. And you can see it looks stretched because it looks wider, but it's also shifted down 1. And there you go. There are the problems 67 through 72. If you guys have any questions, feel free to message me or email me. Have a good day.